And that's really weird. I think when you're in school, you tend to get told in science that you have this line and all the colours go on the line. And in art, you get told you mix 3 colours together, and you get all the colours. That's pretty confusing, isn't it? How can you mix just 3 of them together and get all of them? It's like 3 lines on the graph, and if you magically mix those together, you get all of them. That doesn't make any sense. It's actually very complicated. It's to do with your perceptions. And the talk last week was very much to do with that. I'll try and show you a little bit more over there what I mean. But we'll let this film thin here, this simulation, and you'll be able to see exactly what happens as it gets thinner and thinner and thinner. At 800 nanometers, 700, you can see itself. You can read it. So round about now is the point where we start to see colours. Thinner and thinner and thinner. Notice that these curves seem to spread out. 350 nanometers, still getting some light back. Now there we would see it quite dark, but hey, look, there's one more still to come, the encore, and then it drops down to 0. And at 20 nanometers, it's at 4%, which is barely perceptible, because the response of the eye is non-linear. So there, it's barely perceptible. And what I'm about to show you is to do with exactly that. We did that one. This is a friend of mine who tried to blow some bubbles that she made herself, and as you can see, she failed spectacularly. So if you're going to try this at home, I recommend that you make the mix that I said with the glycerol. Don't do that, because you look stupid. Now, what I tried to do was then take that a little further and try and simulate it. And I used Java, so I tried to simulate it. I got help from my friend called Pete Gravel, who helped me out. And here's a Java application. If I change the thickness of the film, I can change what it looks like. It's going to slide down itself. It's going to be thinner at the top than it is at the bottom. And if I tell it how thick to be at the top or the bottom, and then just assume a constant gradient down, it's a good guess, we can see what the colours are. And that looks pretty good. That's all right. If I make it bigger, if I go up to say 1,000, and then click go, that's what it looks like when it's from 0 to 1,000 with constant gradient, and all the colours in between. It actually looks quite similar to what you saw, right? So it looks like the physics might work out okay. I've tried to animate it too, again with laborious screenshots because I don't know how to do it properly. And if I click here, you should see the soap film thinning, I hope. Yeah, there you go. So the top is thinning. I thought this was the best way to try and demonstrate the colours. And then you see what the colours look like as they come down. And I think you can see them okay actually from back there. So it's gradually thinning. Some of the colours are appearing through. There's some yellow there, some magenta, as I said. There seems to be a black band followed by a yellow band, and then there seems to be black there at the top as well. And then eventually, just black. So the black part of the film, the film where all the colours, all the frequencies destructively interfere, is around 20 nanometers, which is 1/20th of the wavelength of visible light. Tiny. Right, without further ado, we're going to try and see that now over there. Rather confusingly, I've got the experiment there, and you look at it over there. The reason for that is that I need to be very careful about how to put the light. I needed the light source not to be directly shining onto the soap, because then you would just see the bulb of the light source. It needs to be ambient light. So then I've used a white screen here. That screen then scatters the light ambiently to a black screen, because I want to absorb all of the light that goes through the soap. I don't want anything to be coming back and getting in your way. I just want it to be the light that's coming off the two surfaces, one at the front and the back. When I put it in then, you should see something very similar to what I showed you. And the first go may not work. Nobody breathe. It's very sensitive. I put some rope around it so that it would have a better hope of sticking. And the reason I didn't show it to you directly is because it really matters from where you are, so I've used a camera instead. You notice then this first black band that appeared And that's due to the fact that there, the maximum intensity is blue, and you can't see blue very well, so you see it kind of as a black. And that's not truly completely destructive interference, that's more your problem, that's your eye that's not seeing it properly, than the film. As we get to here, you see the last yellow band, and then there's the glycerol that I've added, and that's white. That may start to interfere with itself, because that will have a top surface and a bottom surface. That may start to interfere. And if nobody breathes too heavily, you might see the black surface. So we'll wait. I will motion over very carefully now, try and show you with colour filters all the different colours. There you go. That's bound to happen. I'll show you with colour filters the different colours that come through. And this film, as you now know, is very, very thin and it's very sensitive. If I just move my hand a little bit in front, you see my hand there? Just to prove this isn't a trick, right? It's not pre-recording, it's real. If I move my hand just ever so slightly like this, then all the different thicknesses get sloshed around, and it takes gravity a little while to sort them out. There you go. Now I'm going to use colour filters to show you what I mean by some of the thicknesses acting constructively and destructively. If you look at where green is, green only comes through at some points. It totally destructively interferes at some thicknesses. Red, other different places. Notice, it's a totally different place to where green is not visible. It popped, none of them were visible. Perilous business, this problem. Right, put another one in. Can't go too quick either. And I want you to notice that I said that magenta was an absence of green. No green there, the black bits, and if you look still where those black portions are and I move it away, those are exactly the bits of the pink of the magenta, right? So those are the portions where you're just getting blue and red adding together. If I put blue in, you can't see blue very well, because your eyes, that's a little hazier to see, but again you get some dark patches too. And if we hold out for it to go black, you'll be gazing upon a soap film that's 20 nanometers in thickness. And if you think about that, what does 20 nanometers mean? Well, it means the following. If I give you a scale model, if you take the diameter of the Earth and you compare it to a meter ruler, that's the same step in scale as from the meter ruler to the soap film. Several orders of magnitude. Thank you very much. If you wish to hang around and try it out, I'm probably just going to put it down the sink at the end, so you're very happy, you're very welcome to try it and have some fun. You can't take any of it away.
1 minute left.
Before everyone goes, two little things. We'll do the questions afterwards, as usual. I don't think many people are going to be leaving this time. PhilSoc dinner tickets will, like, Monday's the last day, and if you haven't got your ticket yet, I can give it you at the end. Otherwise, talk speaks for itself. To be honest, it's not really what I
You have mixed feelings, right? You don't want to move too much because it might pop. So gently leave out the back if you're going to go.